Finding and calculating values from a frequency table means that we are going to calculate averages, our averages of mean, median and mode. So here are the definitions just to remind you what we're looking for. As well as our averages, we can also see the range of data in a frequency table, and we'll be looking at how to calculate that also. Here I have a frequency table, and before we start calculating averages from the frequency table, it makes sense to understand what exactly is being given in the way of information. So here we have 50 football matches having taken place. I know it's 50 because the frequency totals up to 50. And on each of these matches, I have here how many goals were scored. For example, in 7 matches, no goals were scored at all. In a total of 13 matches, each match had 2 goals scored. In a total of 4 matches, each match had 5 goals scored. So that's what's being shown. When I'm asked what is the modal number of goals scored, I'm looking for the frequency that comes up the most. And as you can see, the frequency is 14, but the number of goals scored in that 14 matches is 1 goal each match. So the modal number of goals scored is 1. The median number of goals scored is the number of goals that appears in the middle of the data. So again, I'm looking to the frequency column. If I have a total of 50 matches lined up here, halfway through means if I divide that total of 50 matches by 2, I get the 25th and the 26th match. 25th and 26th because in an even number of events there are always 2 events in the middle. So I am looking from the frequency column for the 25th and the 26th match. Here I have the first 7 matches played. If I add the next 14 matches played, I have the first 21 matches. So I'm getting very close to my 25th and 26th match. By the end of this group of matches, I actually have 34 matches have been played. So the 25th and 26th match is in this group here. Therefore, the median number of goals scored is going to be 2. 2 goals scored. The final question is asking me to calculate the mean number of goals scored. And as we've remembered, mean is where we add up all of the values and divide by how many values there are. So in order to calculate this, we have to increase our table size by 1 more column. And this column is going to be the total number of goals scored for all of the matches in the table. I'll explain. The first row tells us that in the first 7 matches, no goals were scored at all. So in those first 7 matches, we have a total of no goals. 0 times 7 is 0. In the next 14 matches, in each one of those matches, 1 goal was scored. So that is a total of 14 goals. In these 13 matches, each match had a goal score of 2. So the total number of goals scored in those 13 matches are 26. I'm going to keep multiplying my frequency by the number of goals scored to find out how many goals scored for all 50 matches. So 3 times 8 is 24 goals. 4 times 3 is 12 goals. 4 times 5 is 20 goals. And 1 times 6 is 6 goals. To find out the total number of goals scored, I've got to total up this column. If I add all of my goals, I have a grand total of 102 goals scored in all 50 matches. So my mean, therefore, is then calculated by dividing the total number of goals scored by the total number of matches, either manually in a bus stop division or on a calculator. 102 divided by 50 gives me a mean of 2.04 goals. And if I wanted to know my range of data, that would be the range of the number of goals scored. So the range is going to be 6 goals, which is the greatest number of goals scored in any one match, minus 0 goals, which is the least number of goals scored in any one match. Doing that sum means my range is 6. This table looks slightly different from my last example because here the amounts of money that anyone spends in Emma's repair shop is estimated and put in a group. So in this particular table, I have 3 people who have spent somewhere between £0 and £10. Here I have 7 people who've spent somewhere between £10 and £20 on the repairs for their bike, and so the table continues. I'll still look for the modal amount spent on any repairs in the frequency column, but you'll see here we're being asked for the modal group. So the highest number in here tells me that 9 people spent somewhere between £40 and £50 on their bike repairs. So the modal group is £40 to £50. This actually says that the cost of the repair was greater than £40 but less than or equal to £50. We're going to estimate the mean now. The fact that it's an estimate means we've got to decide on an appropriate amount that represents the spend of all these 3 people. And we are going to calculate that amount by finding the middle value between these 2. We call that the midpoint, and we shorten it to MP. I'm going to add a 3rd column to my table so that I can note down the midpoint of each one of these groups. So the first group is a number between 0 and 10, so the midpoint is £5. The next group between 10 and 20 is £15. The third group is £25, £35, and the final group £45. So that's my midpoint. Now, just as before, I'm going to multiply the amounts by the frequency. This time I'm going to multiply by these midpoint amounts to give me the total estimated cost of all the people that took their bikes in to repair. So to work out the total spend in Emma's repair shop over the 1 week, I'm going to multiply the frequency by the midpoint. 3 5s are 15, 7 15s are 105, 6 25s are 150, 8 35s are 280, and the final calculation, 9 people spending an estimate of £45 is £405. So here we have the individual estimated spends. Our final calculation is to work out the total estimated spend by adding up the final column. Adding up either in a column addition or by calculator, we see that £955 is the total spend, and that was spent by 33 people. Adding up the frequency, we can see 33 people took their bikes in for repair. When I calculate the total amount spent divided by the total number of people spending, I get a spend per person of £28.94. Therefore, the estimated mean of the cost of repairs is £28.94.